If I could tell my younger self one thing before starting my computer science degree, it'd be that computer science is the science of computers. It is a science. And I very rarely found it useful to know that the computers are run by little green goblins. Should cut that, they can't know. But the truth of it is that you're really not going to be able to churn out an iPhone app a day or build a website one afternoon. In fact, you won't even know why grandma's printer still isn't working or why Netflix just stopped streaming. But what you will know how to do is rotate a 3x3 matrix in binary and delete from an AVL tree in like 2 minutes by drawing cute little diagrams. Yay! And you'll be able to implement different methods of CPU scheduling in Java and then make a really long-winded write-up about it. Computer science is so cool. However, when you end your computer science degree, you typically end up being a software engineer, or more accurately, like a web application developer, which is basically a blue-collar job. You're pretty much not doing a science at all. It's kind of like the difference between an architect and a civil engineer. So while a lot of the degree was obviously quite a bit theoretical and not useful in the real world, there was a lot that I still found useful from this degree that that I've been using for the past year as a software developer after I graduated. And so I want to go over that today after you've liked, subscribed, and told your friends about the channel, of course. So these are most of the notes that I made over the 3 long years of this degree. No, but for real, it was a great time. I guess in first year we covered a lot of basics. Later in first year, there's a lot of object orientation and polymorphism. That sort of stuff is like, you need to know that as a software developer. So that was actually quite useful. Things like sorting and, swing. Swing was gross. Binary and two's complement. Ended up doing a lot of Java, like most computer science degrees. But that still gave me a really solid, I think first year on the whole actually gives you a really solid base. There was obviously some stuff you don't actually use, like, what's this, two's complement. Oh, one other thing. I made a little note here on copywriting. I would like to say that's really useful, but now you can just use GitHub Copilot and steal people's code anyway and pretend that you didn't know that that's how it works. Then moving on to second year. Yeah, second year was a lot more theoretical. What was useful here? I guess all the database sections we did on SQL, normal form theory, don't remember what that actually is, DB optimizations. This has actually ended up being a lot more useful than I thought, understanding indices. Obviously, we delved into the actual structure of how the indices are made and the trees and how, I don't remember. But just having a basic understanding of that, I still find useful today. Otherwise, second year was a lot of like algorithm-based questions and stuff, which I obviously don't deal with at all. Caches and virtual memory. I'd like to say it's useful, but it's not really that important. OS stuff, like kernels and things, kind of useful. Concurrency and thread safety, there actually was quite an emphasis. I seem to remember there were a lot of questions and stuff about this. It's quite useful to understand. It's really not so bad. Most of it I actually find useful. And then we had ASD, which was, okay, I don't remember what ASD stood for, but that was a lot of regurgitating and just learning stuff. All the points that make up a communications and management plan and the rational unified process phases. Agile was obviously amazing to learn. It's basically just we work the whole year, but then we just split it up into little 2-week sprints and just work as if we normally would if we didn't have the 2-week sprints, but have a lot more meetings. Wow, Pareto's law. I didn't know we learned that in computer science. Extreme programming. What else we got? Project scheduling. Testing. Testing is actually I should have paid a lot more attention to this. Although we didn't really go over actually making tests too much. But like unit testing, regression testing, component testing, system integration. Just having a brief knowledge of like, okay, regression testing is like, okay, we made this change. Let's test everything else that might be affected by it, sort of thing. Later in third year, master theorem, divide and conquer, the theory of algorithms, theory of computation. Theory of computation was like very theoretical. Regex is useful though. I mean, I just use AI to give the regex to me or to interpret the regex. But what I really wanted to get to in this video though is what I found the most useful from the entire degree, which really surprised me. And that was all the networking stuff we did, and all the different network layers and like how DNS works, having a good understanding of like, you know, the different HTTP protocols. This module just enables you to really easily troubleshoot issues, whether it's your mom trying to get a Wi-Fi set up or like this connect to the SQL database, you know, what's going on. They set up a firewall here. It just enables you to troubleshoot things that happen quite often. Okay, so that about wraps it up, folks. Pay attention to networks. Pretty much forget about most of the other stuff. Just scrape that 51%. Don't leave your GitHub repositories on public. That is going to come back to bite you and haunt you. How did those first years figure out? How did they find my repository, man? Anyway, like, subscribe, folks. Tell your friends about the channel. See you in the next one.